Alright, I asked you guys in the last video to do problem 5. It's one last example. So let's work it out and see if you got it correct. And then I'll explain what I want you to do for homework for today. So I'm going to do it a little out of order. I'm going to figure out what quadrant it is in. Tangent is negative. So tangent is negative in this quadrant, and tangent is negative in this quadrant because it's all cosine, tangent, sine for the positive ones. It spells ax. All cosine, tangent, sine. So tangent's positive here, so tangent's negative in the other ones. And then it says cosecant is negative. Cosecant is the flip of sine. Sine is negative here, and sine is negative here because sine is the y coordinates and the y's are down there. So this means it's in the fourth quadrant. So when we work these out in the fourth quadrant, cosine is positive, secant is positive, sine is negative, cosecant is negative, tangent is negative, and cotangent is negative. So there's the signs that I'm going to put on them when I work them out. Alright, so first thing we're going to do is write down what we're given. Tangent is negative 5/9. And then we're going to do the reciprocal of that, cotangent. Cotangent is also negative because it's just the reciprocal. Then I'm going to use one of the Pythagorean identities. Now let me find my sheet for you. I can either use this Pythagorean identity because I know cotangent, or I can use this one because I know tangent. I can't use this one because I don't know sine or cosine. I'm going to use this one just because that's the one I want to use. Tangent squared theta plus 1 equals secant squared theta. Tangent of theta is negative 5/9. So when I square that, I'm going to get 25/81 plus 1, which is going to be 81/81. It's hard to say. So that's going to give me 106/81 equals secant squared theta. 106/81. Now I'm going to have to take the square root of that, and then I'm going to have to put a positive sign on it because secant is positive in this quadrant. So I take the square root, and I'm taking the positive one because secant is positive in quadrant 4. Secant is the flip of cosine. Cosine is the x. X is positive over here, so secant is positive over here. So that gives me the secant is the square root of 106 over the square root of 81, which is 9. Now, I need to see if 106 breaks down. So that's 2 and 53. And 53 is prime, so it won't break down. So I know that the secant of theta is the square root of 106 over 9. So then I do the reciprocal of it, which is the cosine of theta. So I flip it. But I can't leave the square root in the bottom, so I fancy 1. The more you practice, the more you'll see how easy it is to fancy 1. And I get this. And cosine in quadrant 4 is positive. So now I have 4 of the 6. Now I've got to get either sine or cosecant. I'm going to do it a little differently. I'm going to use one of the reciprocal identities. Tangent of theta equals sine of theta over cosine of theta. Remember that I said when you get to this point you can use any of the formulas, it'll work. So I'm going to fill them in. Negative 5/9 equals sine of theta, which I do not know, but I want to know, over cosine of theta, which is 9 square root of 106 over 106. To get sine by itself, I multiply both sides by 9 square root of 106 over 106. Okay, over here, since I multiplied by it, it will cancel. So now I have the sine of theta equals 9 times that 9 and that 9 will cancel. So I get negative 5 square root of 106 over 106. The sine of theta is negative 5 square root of 106 over 106, and it should be negative in that quadrant. Okay. And lastly, I need to do cosecant. So that is the flip. So I flip this and I move the negative up top. Oh, but I can't leave square root of 106 in the denominator. Now, these two are going to become 106. So that will cancel with that, and I will end up with the negative square root of 106 over 5. And that is the value of cosecant. Negative square root of 106 over 5. Okay. So we have worked 4 examples. We did 2, 3, 4, and 5. So your homework is on CUDA. It is not the problems from the packet, and also I made everybody have different problems, so you're kind of all on your own. It's called, let me read it exactly to you as it appears on LMS. It is called Using Trig Identities to Find the Value of Trig Functions. That's what we're doing. Okay. But I also want to offer you some extra credit. If you have watched to the end of this video and you have got to this point and you want some extra credit on your quiz tomorrow, and I'll tell you about that in just a second, then if you work 6, 7, 8, or 9, just one of them, and do all 6 trig functions, I will give you plus 1 point for each one that's correct. Now, if you're savvy enough to understand what I'm getting ready to say, you're guaranteed 1 point if you pay attention. Okay? So, and I want you to email this to me. At fwoods@haywoodchristianacademy.org, and in the subject line write extra credit. So if you've watched all the way to this last video and you want some extra credit on the quiz tomorrow, do from the packet 1 of 6, 7, 8, or 9, and then do all 6 trig functions for that one problem. So just one additional example, and I will give you 1 point on the quiz tomorrow for each one that is correct. Now, about your quiz tomorrow, just so you know what will be on it so that you can study, the list of what was on it was under yesterday's assignment, the 29th. To find on the quiz, you had to find the measure of an angle given a picture. You have to draw an angle in standard position. You have to find a reference angle. You have to do problems that are trig on the unit circle, which we did on, I think, Monday, and then linear and angular speed, which we did yesterday. Your linear and angular speeds are graded, and you can look at those. I gave I gave more than half partial credit. If your problem was worth 10 points and you got 7, that means it was wrong. I gave you 7 points for doing it. If your problem was worth 5 points and you got 2, it means it was just wrong. I'm only giving partial credit because you did it. So please check the answers, and I'm going to upload another video on linear and angular speed tonight for the person that asked. So if you've gotten to this far in the video, here's an opportunity for extra credit. Here is homework. I will Zoom y'all again on Monday, and I hope y'all are having a great day. Love you guys bunches, and we'll talk to you Monday. Bye.